You see, we have numerous types of triangles. Among all the cases we have seen, there could be many type of triangles as well. In which, why this right angle triangle is so much special? Means, given any type of triangles, see, let me say this is scalene triangle and this is equilateral triangle, and then here we take isosceles triangle, obtuse angled triangle, acute angled triangle, whatever triangle, in that it is easy to split the triangle into two right angle triangles by simply drawing an altitude. This triangle also, this like we can split, or else the altitude we can draw here. We consider this is right angle triangle. So, it is evident that this right angle triangle is a silent partner of all the type of triangles. So, if we catch hold of that right angle triangle, we can control all the triangles. Is it or not? This equilateral triangle is not listening to our words. What we can do? We'll call our guy the right angle triangle. We'll operate using him and we'll make him to do what do we want him to do. Okay? Understood? So, that is why that right angle triangle is important. Now, in that right angle triangle, we already know that one angle is 90 degree. That is why it is that is why it is called as right angle triangle. Okay, and there will be one angle. That angle we can measure it as theta, and this angle is acute angle. Okay, or we can call it like acute angle. Small things which are small, we are calling it as cute, right? Kitty, cat, doggies, like this. This also small, cute angle. How much cute? It's between 0 and 90 degree. Small angle. Okay. And we are mentioning that angle by theta. What is this theta first of all? A Greek alphabet. Theta is an alphabet. But English language has only 26 alphabets. This is an alphabet from some other language. Maybe Greek or Latin, German. We don't know, but some other language. This theta is an alphabet. Why we are using that one? Because those people only derived these things. That is why they have used their alphabets. You imagine what if we Tamils have discovered this everything? Instead of theta, we could have given then the whole world is using would be nice. But they found that, so we are not using this. We are using this so that universal understanding, for universal understanding. Okay. Now, in all the cases we discussed previously, like in the first case, you have found the height of Malakottai. Is it or not? That rock fort height you have found. How you have found? You stood on the top of Sarda's building and you are seeing that Malakottai rock fort, and we know the distance between ourselves and that rock fort. Then, by considering this is right angle triangle and by measuring the angle in which you are looking the rock fort, you can simply find this height. After that, with this height, if you add the height of the Sarda's building and you can get the height of rock fort. For that, one thing plays a vital role. It is the side. What are all the possible ratios of this side? First, we have to name it. Simply drawn on right angle triangle. Let us name it ABC traditionally. ABC. Okay. And what are all the possible ratios? We can write this AC by BC in one possible ratio, and then AB by BC is one possible ratio, and then AC by BC is another possible ratio, and reciprocals of this BC by AC is one possible ratio, BC by AB is another possible ratio, and BC by AC is another possible ratio. Oh, BC by AC I written 2 times. Sorry, my bad. See, AC by AB, man. Sorry. AC by AB. Then here, AB by AC. So, only these ratios are possible. Apart from this, any other things are possible? No. So, in wherever the situation these things comes, is it okay to write everything in the same manner like AC by BC? Wouldn't be time consuming, right? Wouldn't be time consuming? Time consuming. Okay. So for that we are giving them a name based on the position of theta. Look at this guy AC. He is straight opposite to theta. So he has been called as opposite side. Okay. And this guy AB coincide with is adjacent with theta. So this side is called as adjacent side. Okay. And we are rewriting this ratio. Also another thing I forgot. The longest side in the right angle triangle is the side opposite to the 90 degree is called hippopotamus. Is it? I am writing hippopotamus. Hypotenuse. Okay. I have seen one meme, man. And hippopotamus is lying on this hypotenuse, and they are sarcastically showing this right angle. Okay. Now we will redefine this. AC is the guy who is opposite, and he is our hypotenuse, and this guy is adjacent side. Why I am doing this? Because if you stick on to A, B, B, C things and all means, it will stick on to this triangle only. But what you are looking for, a generalized one. Whatever triangle is given, whatever name it has, it should be useful. That is why I am writing. So opposite by hypotenuse, adjacent by hypotenuse, and this adjacent by, oh sorry, not adjacent, opposite by adjacent. Okay. And this guy is hypotenuse by opposite side. Okay. And this is hypotenuse by adjacent side. And this one adjacent by opposite side. But this also sounds confusing. Every time we can't use. So we should give them a name. We should give them a name. Sin theta. Why theta? He is opposite to theta and hypotenuse. And this is called as cosine theta. Why theta? Adjacent to theta. Cosine theta. Okay. And then this one tangent theta. Or theta? Tangent theta. Okay. And this guy over here is cosecant theta. Cosecant theta, and this guy is secant theta, and this one is cotangent theta. Can you observe anything? We have sine, cosine, tangent, cotangent, secant, cosecant. Okay, sine, cosine, tangent, cotangent, secant, cosecant. So these are 6 ratios. This name is also big. So what we are doing is, we are going to shorten that name as well. That name is, instead of SINE, we are writing sin theta. Instead of cosine full name, we are writing cos theta. Instead of tangent full name, we are giving a short name, nickname, tan theta. And this guy is cosec theta. Okay, sometimes we will use CSC theta in very short. CSC means this is not computer center, cosecant. Okay, and then secant means SEC, sec theta. Tangent, cotangent means cot theta we will write. Okay, any doubts in this? This is how this sin theta, cos theta, everything came. Yes, ask me. See, no. First, we have written these ratios. These ratios only named after this sin theta, cos theta, everything. It will not comes like because of sin theta, we are not writing opposite by adjacent. Okay. This ratio fixed on one name, that is sin theta. That is all. Now, we are going to learn about the reciprocal relationship. Who is reciprocal of whom? Who is reciprocal of whom? You see, this sin theta is AC by BC, right? This AC by BC is reciprocal of whom? If you reciprocal it, like let me reciprocal it, 1 by, like I am writing means it will reciprocal, right? So 1 by sin theta means BC by AC. Where you are seeing BC by AC? Cosec. Likewise, if you reciprocal the cosec theta, what you will get? Okay. If you are reciprocaling that cosecant theta, then what you will get? Yes, that is sin theta. You see, 1 by cosec theta equals AC by BC. So they are called as reciprocal of each other. Cosec is the reciprocal of sin, and sin is the reciprocal of cosec. Okay. Likewise, can you find any other reciprocals? Take cos theta. 1 by cos theta secant theta, and 1 by secant theta cos theta. Then 1 by tan theta cot theta and vice versa. 1 by cot theta is tan theta. Okay. Now have you understood why we are calling this using this name? Why only there are 6 trigonometric ratios? Why it is specifically right angle triangle and no other triangle? And who is reciprocal of whom? Now answer me this. What will happen if you multiply sin theta with cosecant theta? Sin theta into cosecant theta, then that is sin by sin, it turns out. Sin by sin means 1. That is all. Is this a formula? No. Don't count it as formula. Just the basics definition. And this like, can you say any other? Perfect. Tan theta into cot theta equals 1. And then cos theta into equals 1. Okay. Wherever required, we can use everything. Now imagine that instead of this notation, we are writing every time opposite by hypotenuse. Hypotenuse by opposite is equal to 1. Tiring, right? That sounds itself tiring, time consuming. That is why we are using this. Otherwise, we could have never used it. Okay. That is the reciprocal relationship. Now, when you look at this angle theta,